All right, so today our objective is that you know the difference between an inequality and an equation. That you can verbally represent an inequality and that you can determine if an inequality is true for a given value. And then you're going to be able to graph these inequalities. All right, so if you haven't already, these notes are on Schoology for you to go ahead and print and follow along as we go. And if you don't have a printer, that's okay. There aren't a whole lot of notes. Just make sure you take the notes as we go. Take a picture of them and submit this for an easy grade to show you that you've watched the lesson and you followed along and you did the work. So an inequality is actually very, very, very similar to an equation when we are solving it. So I know we're just getting into it. So today we're going to talk about some inequalities, but it is when you're solving them, it'll be very much like equations. So we shouldn't be adding too much. This intro is going to get you back in the feel of what you should already know about inequalities to prepare us for actually going ahead and solving inequalities, which you really should already be able to do because you guys rocked equations. So an equation is what we've been talking about, using an equal sign to show you that the left and the right are the same. An inequality, however, shows that both sides are not the same and not equal, because we know equivalent, if you want to draw a line and insert that definition, we know means that they're equal. So greater than is going to say, and we read from left to right, so greater than is going to say this is greater than this. So the bigger side is the side that is greater. So and then greater than or equal to is going to include a line because this is greater than, but it also could be equal to the number. Less than, whatever comes first is less than the second number. Less than or equal to, or not equal. Okay, so this is going to require a little bit of our knowledge with some integer rules as well as decimals. So first, I just have two regular positive numbers. Actually, I want you to go ahead and pause this. Fill these out, and then I'll go through it because I want to see. This part should be review. It should help you remember your integer rules, and then I'm going to go through it in just a second. So pause this and do A through E. All right, let's see how you did. This first one, they're two regular positive numbers, 4 and I have 9. So we know with our regular counting numbers that 9 is bigger than 4. With our decimals, we're still just going from left to right. So they both have 0. So we're the same so far. So then we can go ahead and move to the tens place. I have a 5 in the tens place and a 4 in the tens place. So 5 is greater than 4, or 5/100ths is greater than 4/100ths. So I can stop right there. All right. So remember, our negatives work differently. When we are talking about positives, they get bigger from left to right. And our negatives get bigger from left to right. So what it tells me is that it's going to get smaller as I go from right to left. So both of them from 0 are counting up from 1. So 0, 1, 0, negative 1. 0, 2, 0, negative 2. So the further left we go, the smaller it's going to get. So I have negative 3. And right before negative 3, I have negative 2. So negative 3 is smaller than negative 2. If you think about it, and I say this a lot in class and lessons, but I like to think of negatives with money. If I owe you $3 and I owe my mom $2, I owe my mom less money because I don't have to give her as much of my money. If I'm giving her $2 and losing $2 to my mom versus losing $3 to you. Think of it as a loss. You're losing less the smaller it is. All right. So same thing here. These are both negative. So I have negative 6.1. So negative 6 is the same as negative 6. Negative 1 is the same as negative 1/10. I'm sorry, negative 1/10 and negative 1/10 are the same. And this is a 0. Anything after that is assumed 0 as well. So these right here are going to be equal. All right, so here, again, two positive numbers, so we're just going to go left to right. I know my 12s match up, but let's look at my 10s. 4 and 0, left to right. 4 is bigger than 0. Awesome. Did you get all of these right? Awesome. I knew you'd rock that. All right. So here we're going to write a verbal description of the inequality statements below. So we're just going to use these symbols, and we're going to read it from left to right. What is this? That's right. 6. What symbol is this in our chart? 6 is what? Less than or equal to. So 6 is less than or equal to x. All right, so what if I read it backwards? I could say 6 is less than or equal to x because that's what it says. But another way to write that is, what if I had x, well, x has the big side, so x is bigger, is greater than or equal to 6. All right, let's go ahead and look at this next one. We're literally just reading what it says. What is that? Y. What does that say? Less than. So is less than. What is it less than? What number is that? Don't say 0.5. 5/10. And we know that this top one is less than or equal to, and this bottom one is just less than because of that line. That line tells me or equal to, and without it, it does not. So y is less than 5/10. What if I read it backwards? 5/10 is less than, well, not is less than, because we're going backwards. So 5/10, because we're starting right to left, is the opposite. But what's the opposite of less than? Greater than. Why? We know this is true because 5 has the big mouth. So 5 is 5/10 is greater than y. All right, so we're going to use that variable as the starting point when reading our inequalities. So all this up here really should have been reviewed. Let's look at some other stuff. This is going to take what we used, I believe we learned this last year. We're going to substitute that that value in for our variable. Before we were just substituting it in to figure out what we'd get. Now we're going to substitute in and see if we get a true statement. So we said k plus 8 is greater than or equal to 19 if k equals 11. So our value of k is 11. So we're going to take k, right, 11 plus 8 is greater than or equal to 19. Well, what's 11 plus 8? 19, greater than or equal to 19. Well, is 19 greater than 19? No. But it also said it could be equal to it. Is 19 equal 19? Yes, so it's true. Awesome. All right, so I'm going to go ahead and I'm going to move around a little bit. I'm going to do 1, 5, and 8. All right, so let's look at 6. I have 6 is less than b minus 8 if b is 22. B is 22, so we're going to replace b. 6 is less than 22 minus 8. And what is 22 minus, and this is not 6, this is 16, but I covered up the 1. What is 22 minus 8? That's right, it's 14. So is 16 less than 14? No. So it's true. No, I say no and write true. So it's false. And actually, I'm going to do 1, 5, 6, and 8. I think that's good. All right, so let's look at 6. I have x is 5. So I have 6 times 5 plus 5 is less than 18. So this can kind of make you think. In order to undo our equations, we're doing them backwards. But right now we're doing them. So we're going to go in the proper order. So we're doing our order of operations regularly because we're not undoing them. We want to solve them. We want to actually work them out. So multiplication comes before addition. So 6 times 5 is 30 plus the 5 is less than 18. And then 30 plus 5 is 35. Is 35 less than 18? No, so that is false. All right, and then let's look at 8. That's what I said was my last one. All right, so I have 5r minus 3 is greater than or equal to 25. If r is 6, so we're going to go ahead and say 5 times r, which is 6, minus 3. Well, 5 times 6 is 30, because multiplication comes before subtraction, and 30 minus 3 is 27. So is 27 greater than or equal to 25? 27 equal to 25? No. Is 27 greater than 25? Yes, this is true. All right, so now I want you to go ahead and do, let's see, 4, 7, and 9. I want you to pause this. I want you to work out 4, 7, and 9, and then when you are done, unpause it, and I will go through them with you. Take that value, plug it in, see if you get a true or a false statement. All right, did you already pause it? If not, do it now, because I'm going to start doing it. All right, so we should have already worked these out. We're going to plug 13 in for C. So 13 minus 12 is greater than 30. Well, 13 minus 12 is 1. Is 1 bigger than 30? No, that's false. All right, how about 7? I have 2 times j is less than or equal to 8. Well, j is 5, so 2 times 5 is less than or equal to 8. Well, what's 2 times 5? 10. Is 10 less than 8? No. Is 10 equal to 8? No. So this is also false. Let's do it one more time. I have 6 times m, and we have the m is 8. So 6 times 8 minus 12. Multiplication or subtraction first if we're going in the proper order. That's right, multiplication. So 6 times 8 is 48. 48 minus 12 is 36. Well, it tells me that, and I should have done it as I went, is less than 40. Is 30 less than, or sorry, is 36 less than 40? Yes, so that is true. Awesome, did we get those? We know how inequalities works. The smaller side means less than. The open side that you're eating with is more than. All right. So, inequalities can also be graphed on a number line. Oops. On the number line. All right. So, included, that filled in circle is less than or equal to or greater than or equal to. If you're including the number that you're talking about, you're going to bubble in that number. So you're going to fill in the circle. If you're not including it, it would be less than or greater than. because you are not including it. So you leave it open so you don't say that I'm also including this number. So I have 5. I know that it is or equal to. So at 5, I'm going to fill in my circle because I know I'm including that 5. And then I know that it is less than. X is less than that. So I'm gonna go ahead and say X is less than 5. So my variable is anything less than 5. Well, we know the further left we are, the smaller we get. I'm going to show you a trick. And this only works if the variable is written first. That variable is on the left. The inequality points which direction you shade. But that only works if the variable is on the left. All right, so let's do some practice. I'm going to do these first 3, and then I'm going to have you do the second 3. All right, so I have K is greater than 11. Well, first, I know I'm starting at 11. Is it going to be a full circle, a shaded circle, or an open circle? That's right, an open circle. Why? It doesn't include 11. Is our variable first? So we can shade that direction that it's pointing. K is greater than 11. Does this show that all the numbers, what direction are all the numbers bigger than 11? So right, does that show that all those right numbers are bigger? All those numbers? Yeah. All right. So we have 12 is greater than F. And like we were writing before, if we read it backwards, F is less than or equal to 12. So all I did was flip it. So I know F is less than or equal to 12. So we're going to do 12. Is it a shaded or an open circle? Right, it's shaded because we're including 12. Now that I have F first, so all we did was flip it. We flipped the numbers, so we flipped the signs, and we pointed it the direction. So let's look at though and make sure we say, is 12 greater than all these numbers I have for F? Yes. All right. So D is less than 6. Open or close circle at 6. Open. Are these numbers less than 6? No. Are these numbers less than 6? Yes. And D came first, and we shaded the direction the inequality was pointing. Awesome. So now I want you to fill these out. Pay attention to 14B does not come first if you're using my trick. Awesome. So let me go with our bubbles first. I have C is less than 25. Is that an open or closed circle at 25? You pause this and fill this out, right? Awesome. So that's right. It's open at 14. Open or closed at the 0. Closed because we're including the 0. X is greater than or equal to 4.5. Closed or open? Closed. Why? Because it includes it. That's right. And where's 4.5? That's right. Halfway between 4 and 5. Awesome. So now let's figure out which direction we're going. C is less than 25. What numbers are less than 25? The numbers to the left of it. All right. How about this next one? I have 14. I have 0 is less than or equal to B. So I'm going to read it as B is greater than or equal to 0. So all of the numbers bigger than 0. 0 is less than B. And all these numbers greater than B to the right. All right, I have X is greater than or equal to 4.5. Which direction are the numbers greater than 4.5? To the right. Awesome. And we know because X came first, we shade the same direction. Awesome. All right, so look, based on the verbal expressions below, write and graph an inequality. I have the McDonald's family spends no more than $150 per week. So if I'm not spending more than $150, what numbers am I talking about? What's not more than? Less than. So 150 is the absolute top that it can be. Can it be 150? Yes. So however much they spend has to be less than the 150 cap. So we're going to put 150, 160, 140, 130, 120. I'm starting at 150. Open or close circle. Close circle. Which direction am I shading? What numbers are less than 150? To the left. Perfect. All right. I want you to go ahead, pause this, and work out 7. All right. What did you get for your inequality? Jared earns at least $10 per hour when mowing lawns. Well, he's not going to make any less than $10 per hour, right? So 10 is the smallest it can be. Anything else will be bigger than 10, right? So whatever this is has to be bigger than 10 because he's not making any less than it. Can he make 10? Yes. So let's say 5, 10, 15, 20, 25. Well, we said he couldn't make anything smaller than 10, but it could make 10. Awesome. Did you get that? Rock on. All right. So I'm going to talk about what we learned today. And as I'm doing that in your own words, you should summarize today's lesson. I will be looking for that when I grade your guided notes. So our objective was that you know the difference between an inequality and an equation. What did we say the difference was? An equation shows that both sides are the same, and an inequality shows that they are not the same. Awesome. Can you verbally represent an equality? You can show that x or whatever variable is greater than or less than. You know how to read an inequality. We've done that before. Awesome. I can determine if an inequality is true for a given value. You know how to plug in values for variables. And you did so quite beautifully with me. And then you did on your own quite beautifully. And we know how to determine whether or not these numbers are greater than, equal to, less to determine if they were true statements. And we can graph an inequality. We know that an open circle means it does not include. A closed circle means, yep, this number too, so I'm going to shade in to say also this number. Anything bigger than this, we know these numbers are bigger and these numbers are less than. And I drew them from a circle, but you can use greater than or less than with either of these. Awesome. So I want you to go ahead and make sure you turn in the guided notes on this, and then we will do some more guided practice on this today in class. All right, guys, have a great day. Bye.